Okay. Alright, so what I want to do here is go ahead and answer any questions that you guys have about either the worksheet or the homework problems. After we get done, we're going to talk about the lab and we're going to get started. So today we'll probably be able to do the beginning part of the silver nitrate lab. There's some hazards we have to go through so that you understand exactly how dangerous this lab is and why you have to be extremely careful. You may be able to start the copper and iron lab, which if you do, you just have to be careful with. And my guess is either Wednesday or Thursday you'll start the yellow paint lab, and then we'll get all three labs done. Now, since I did send you guys the email, you guys should know what the data table is going to have to look like. And there's a lot of data, and you guys cannot get it confused. All right? You have to know what data goes with what lab. Yeah, we'll do that all week. You're going to have to do something to get it done because the one lab will take 5 days to run. Okay, the silver lab will take 5 days, and we want to finish on Monday. Because if we let the thing go any longer, it's just more time that we're just doing all sorts of stuff. So if you're not going to be here one day during the week, yeah, plan on spending a CP in here. What you probably want to do is call the Pope and ask him if it's all right that, well, in case.
Because, do you remember that day?
Oh, I'm sorry.
I don't know.
Okay.
Did she decide to?
Well, when you find out, let me know and we'll work it out. Okay? Because that's totally different than if you were just deciding to go on vacation. Like some other person in this room did.
It's not a vacation, it's here.
Yeah. All right. So now, go ahead and ask some questions because I'll answer any of the questions that we have over the worksheet. Or the textbook, yes. Yeah, okay. We can do anyone out of what you want.
120.
Okay, which one is 120?
I thought it was 121.
No, 120 was the one that you guys had to do. 121 was extra credit. If you wanted extra credit points, you did 121.
Can you tell us the answer for 118?
Yeah, 118, the answer, final answer is, taking an screenshot of it as you cycle back and give the answer. 2.7 times 10 to the 5th kilograms.
What? What? Yeah, that's not what I got.
And let me go back up here a second. Oh, how about 4.1 times 10 to the 8 grams?
Okay, all right.
Right.
All right.
So it's 4.1 times 10 to the 8 grams.
I was gonna say, I don't know.
Number 120, I'll tell you the answer is 75%.
You have to do it.
So, hang on. The answer is 88%, it's step 3. Alright, guys, this one here is how it works. They give you a 3-step process. Okay? And in the 3 steps, they have the first one starts with C6. The second one starts with C6 again. C6, H8, ON, Cl is the second one. That's the beginning compound. The first compound is C6H5, O3, and the third reaction begins with C6, C6H7, ON. And here's the thing we know. In the first reaction, the percent yield of that reaction is around 87%. The third reaction is about 98%. Okay? And what they do tell you is, going down here to 120, they want to know two things. They want to know what the percent yield for the third reaction is, and they want to know the total percent yield. Are you guys with me so far?
Yeah.
Are you guys just copying and not listening, or what?
Listening.
Or you're copying and not listening?
Both.
Alright.
Copy and listen.
So here's what they tell you. In this chemical reaction, if we start off with 4, it says the overall reaction yields 3 moles of acetaminophen product for every 4 moles of this compound. So you're starting out with 4 moles of this compound, and you're ending up with 3 moles down here of acetaminophen. Well, I guess the first thing we better do is figure out what should be produced in this reaction. So I look at the first problem. And if I notice very carefully here, all these equations are balanced, right? So in the first one, if I started out with 1 mole of C6H5O3N, I should end up with 1 mole of C6H8ONCl. You guys see it? Well, that means that I'll have in the second equation 1 mole of that C6H8ONCl, which will produce 1 mole of C6H7ON. And 1 mole of C6H7ON will produce 1 mole of C8H9O2N, which is acetaminophen. So let me ask you this question. There seems to be a one-to-one relationship between how much I start with here and how much I end with acetaminophen at the end. Question. If I start out with 4 moles of this compound, how many moles of acetaminophen should I have produced? 4 moles. So I should produce 4 moles of acetaminophen. The acetaminophen, this here is the starting product. The acetaminophen is what we end with down here. And if we looked at the equation, I didn't write them out, it just went 1 to 1, 1 to 1, 1 to 1. So if I start out with 4 moles of this, I better end up with 4 moles of acetaminophen. But I only have 3 moles of acetaminophen. What's the percent yield?
75.
The answer is 75%. Because all I do is go 3 moles over 4 moles, and that is 75%. There it is. Now, what that gives us is this number here, 75%.
But we don't get that.
The thing we don't know is what is the percent yield of step 3. So how would you determine the percent yield of step 3? Well, let's think about it. The 75% is the overall percent yield. Okay? Like in the first step. If I were to say that this was a step, and let's go with something really simple. If I had 1 mole of this, I would produce 0.87 moles of this, because it's only 87% efficient. The next one is if I start with 0.87 moles of this, being 98% efficient, my guess is you probably end up with 0.86 moles of this. Now this one here, I start off with 0.86 moles, and all I know is that this answer here must be 75% of what that answer there is, which means that it's going to be 0.75 moles. So what I need to know is, what is the percent yield in this particular case?
75, 86.
Well, let's think about this a second. If I were to ask you what the overall rate of reaction was for those 2 steps there, how would you figure out what the overall percentage is, or the overall percent yield is? Okay. Do me a favor. Do this for me. Take 0.87 and multiply it by 0.98 and tell me what you get.
We're all so lazy. Okay, calculate.
0.8526.
Point what?
0.8526.
8526. I'm going to tell you right now, here's what this means. If I took a look at both of these reactions, the overall percent average is 85%. I have an 85% yield or 86% yield at the end of the second step. Now you may think average would come into play here, but it doesn't. Remember what I did before? Is I said that in the first step, if I started out with 1 mole of the compound, at the end of the first step, I would have 0.87 moles of this compound. Okay? The second one is I start with 0.87 moles. Surprisingly enough, the end result here, or 98% of that number, is about 0.86, I think. Somebody take this number and multiply it by 0.98. Somebody do the work that way. I know I'm coming up with
Just
a...
did it.
Yeah, 0.8526.
Okay. What is it?
0.8526. It's the number that you have already got down.
Okay. Okay, now, the next step says, is I start off with 0.85 moles of this, and what I want to know is, I know that the overall reaction now is going to be 0.75. Now let's think about this. In order to end up with this as my overall reaction, all I did was take these two numbers and multiply it to come up with that percentage, right? What if I told you that now I do 0.87 times 0.98 times x is equal to 0.75? Can you figure out what that number would have to be in order for that to come out to be correct? So what I've done here is said, okay, if I just wanted the overall reaction for the first two steps, I just multiply the 2% errors, or percent yields, and it gives me what the overall percentage is. If I want to do it for a 3-step problem, I would have to multiply the percent yields of all 3 steps, and I get the overall, but I already know what the overall is. 0.75. So what did you come up with?
0.88.
0.88? Which means that the third step right here, the third equation, going back up here, 88%, we're done. We're done with the problem. Was there high-level mathematics involved here? No, not really. No, not really. Yeah, and that's one of the things about these problems is that they're there to make you think. That's why they're called challenge problems. Okay, what else?
What was number 1? I just want to know number 1 on the one when it talks about pure oxide reacting with hydrochloric acid. What was that answer?
Number 1, ferric oxide and hydrochloric acid. I don't know the answer. I don't have the answer down here.
Oh, okay. I just wanted to know if I was doing it.
Well, let me ask you this question then. If we were to do that one, first of all, I'd have to do ferric oxide, which is Fe2O3 plus HCl. According to Nina, would give me H2O plus FeCl3. That would be the chemical equation.
Is that?
I would probably go with a, let's go with a 2 here. Let's go with a 6 here. Let's go with a 3 there.
All right.
And that looks pretty good right there.
Okay.
I got that.
Now, the first step is I'm going to have to determine which one is the limiting reactant.
Yeah.
So what I'm going to do is I'm going to go 139.9 grams of Fe2O3. And what I'm going to do is a stoichiometry problem from Fe2O3 to HCl, which will tell me how much HCl I happen to need. So I would have to go through, and someone, if they've got a calculator, make my life a lot easier. Can you tell me what Fe2O3 weighs?
159.
Yeah, 159 point
0.6882
grams, and that's Fe2O3. That's 1 mole
Right.
of Fe2O3.
Okay.
According to this, it states that for every 1 mole of Fe2O3, there are 6 moles of HCl. And I know that 1 mole of HCl weighs 36.46094 grams of HCl. And so what I can do now is just go ahead and calculate this math work here, and what does this come out to be?
191.7.
191.7? Okay, 191.7 grams, I'm assuming you're right, of HCl. So this is how much HCl I need. That's not weed, that's need. It looks like weed. Question, do I have enough HCl?
Yeah.
How many grams of HCl do I have according to the problem?
45.
I have 45.6. I need 191.7. Do I have enough? No. Because this is again how much I have to have in my possession, and all I've got is 45.9. So that makes this the limiting reactant. Now it says what mass of water is produced, the other product is aluminum chloride. So now what I'm going to do is go ahead and do my stoichiometry, and it's going to go 45.6 grams of HCl. I know that 1 mole of HCl weighs 36.46094 grams of HCl. According to this, for every 6 moles of HCl, there are 3 moles of water. And for every 1 mole of water, it's 18.01528 grams of water. So now all I can do is solve it. And in this case here, what does it come out to be? So 45.6 times 3 times 18.01528.
01528. I said 01528.
Yes. And you divide that by 36.6 or 46094 divided by 6. 11.26. And there's your answer to the first problem. What'd you come up with? Yeah.
I didn't get that.
I got 11.
Because, well, I didn't do number one. A teacher came over and helped me with this.
Okay.
Okay, and he did it a different way. Well, yeah, and he told me how to do it. But it's kind of like that, but it was different. Like,
Did you come up with the right answer?
No, that's what I'm saying, no.
Okay, so what did he do?
He did the ferric oxide, and then he did that, and he divided it by the content.
Okay.
And then he got 0.876 moles. So when he did that, Kevin did it through, he had to label himself.
And see, that's why you need labels.
Huh? Yeah. Yeah. And then he had the 6 moles of HCl over 1 mole of ferric oxide, and then yeah, I put labels on myself, and I did it.
Mr.
He did it.
That's it. This is
Who? No, I do not have Train Anderson in my classroom. Oh, China.
Train
I thought you said Train.
Hey, Train.
Okay, so yes, I do have China.
Choo choo. Choo choo.
Sure.
I thought that was.
Freshman Academy.
Freshman Academy choo choo.
Okay, can you on?
Okay, so then he did a 6/1, and then I think, I don't know exactly. Okay, I think he got 5.6 moles.
I will tell you right now that when he did 6/1,
Yeah.
that's right, that's keep on,
Okay, and then he got 5.256 moles of HCl needed.
okay,
And then over here he got 45.6 grams, and then he left that alone. And then he put down 45.6 grams, he divided that by the compound of hydrochloric acid.
okay.
And he did 1.25 moles of what he had, I think. Okay, so he did some more work, and he got 0.20085 needed for the ferric oxide. And then he took the 1.25 moles of HCl that he had, because he found that he had the HCl as a limiting reactant too.
Okay.
So he had the 1.25 moles that he had, and then he did that, some moles of HCl, and then he did 1/3 because he reduced the 3 over
Okay, which is fine.
Yeah, and then he did the 18.0, and he did 18.0153.
That's fine.
Yeah, and then he put it over 1 mole, and then he just multiplied it out.
And what did you come up with?
Unless he multiplied this wrong. Yeah, 7.5 was true.
Okay, do me a favor. And what we're going to do is go back here. And what he did is the following.
But I can, I don't know, like, if I was saying, like, use myself a little.
Okay. Why don't you do that? Go ahead and write it out. Show me exactly what he wrote down, and then we can make. Hang on, before you do anything, let me do this. V2O3 plus HCl yields H2O plus HCl3. So I have a balance equation. Okay, go for it. I had 11. I came up with 11.2.
What did you take?
That's fine. You got to understand that we're going to come up with different answers because we may round differently, or we may come up with a different mass because we rounded differently,
Or we use a different periodic table.
or use a different periodic table. And please understand that if you're that close, you're okay. The only time that I'd say,
Oh, she is?
you are going to kiss her after all this, right? She's rubbing around and stuff like that? Okay. Yeah, I think I'm a birthday present. All right. Okay. So that says you needed 5.256 moles of HCl. That's correct. Okay. Okay. So far, everything is perfect. Okay.
I can't really read this. I think it's the shape of it.
That's going to be, okay. That's how many moles of HCl you actually have.
Yeah, okay, well, he had that. I don't know. I think he was ready for the
It's got to be 3. That's got to be 3. No,
Yeah, I know this
it'll
blue,
be,
this blood that green eyes.
it should be,
And then, I don't know if that should be.
I told her I was,
Okay, what he
my
should have done
eyes
here-
is green, like everything.
is this should have been 1/3. Because you're going from here to
And I
here.
was like, what you
So what should have happened is moles of HCl should be on the bottom, which is 6. And the top number should be 3 here, which would be come out to be 1,
Steal her.
2.
Playing her for the rest of my life.
Yeah, 'cause they keep it
That baby.
And see, that's where you did wrong, because you just half of this. All you're going to do is take half of that.
They, I don't know, they told pictures and stuff.
Oh, this big thing is right here. That should be 1/3. Or 1/2, not 1/3. That's the only difference, sir. That's the only difference that he made. Yeah, so you just scooped up there. So the mole ratio is just wrong. Okay, what else?
Number 3.
Number 3?
This one was wrong.
Okay. Number 3, it says when 89.32 grams of silver carbonate, even though it does say sliver carbonate, it is silver carbonate. And most of you guys know that silver carbonate is Ag2CO3. Okay? And it reacts with 100 grams of stannic oxide. Well, stannic oxide is SNO2. And what that's going to produce is a stannic carbonate, which is going to be SN parentheses CO3 close parentheses twice, plus Ag2O. So there is going to be the actual chemical reaction. It's a double replacement. To balance this equation, the first thing I'm going to do is go with a 2 here, a 2 there, and oh, you gotta put 2 here, and gotta put 2 here.
I don't have any in front of the SNO2. I have a 1.
Oh yeah, that should be a 1.
And then it
That
should
should
be
be a
2 in front
one.
of the AG. And that's then should be yeah.
Okay.
That's what I got.
Okay. Now all you gotta do is, children, please understand I have all this all on tape. Parents say, what is my child doing during class? It'll be really simple. Go to YouTube and then listen very carefully in the background and you will hear Felicia. Felicia will be talking through my entire time up here. So in case you want to know what we did in class, that'll be it. Alright, so anyway, I've got to go out and figure out which one is going to be the limiting reaction between the silver carbonate and the stannic oxide. Well, I'm just going to do this. 89.32 grams of silver carbonate. So that's Ag2CO3. And what I'm going to do is do the stoichiometry problem between those two reactants. So the first thing I need to do is I need to figure out what the formula mass of silver carbonate is.
275.745.
What is it?
Oh,
275.745.
Okay, hang on. 275.53 grams of Ag2CO3. That's going to be for 1 mole of Ag2CO3. According to this, for every 2 moles of Ag2CO3, there's 1 mole of SNO2. And then I have to figure out what does 1 mole of SNO2 weigh. And so I have to take the weight of silver, or tin, and 2 oxygens.
150.7088.
150.7088
7088.
grams of SnCl2. So now all I do is do the math work. 89.32 times 150.708 divided by 275.7453 divided by 2. And the answer comes out to be approximately 24.41 grams of SNO2. So that's how much I need. Now, the amount of silver oxide I have happens to be 100 grams. So do I have enough? Yeah, I have more than enough, which means this one here must be in excess, which makes this the limiting reactant. Now what it says is they want to know what mass of standard carbonate is going to be produced. So now I'm going to run a stoichiometry problem from 89.32 grams of Ag2CO3. First part's easy because it's going to be for every 1 mole of Ag2CO3. It's 275.7453 grams of Ag2CO3. According to this, for every 2 moles of Ag2CO3, it's 1 mole of SnCO3 twice. So now I have to figure out what does 1 mole of SnCO3 weigh. So I'm going to take 6 oxygen, so it's 15.9994 times 6 plus 12.011 times 2 plus silver or tin, which is what, 118 something?
Let me see.
118.710?
118.710, yeah.
So that's going to be 238.7284. So now I just go ahead and multiply times 89.32 divided by 275.7453 divided by 2. And the answer I come up with, the amount of stannic carbonate will be 38.7 grams of that compound, and we're done.
What was your limiting reactant?
The limiting reactant would happen to be the silver carbonate.
See, because I did it a different way, and I got my limiting reactant to be stannic oxide, and I still got the same answer.
Then you got luckier than all get out. Because it should not have happened.
What was the answer?
38.7.
Okay, 38.2.
No, that's good.
I have 38.6.
Trust me, that's really good. What did you come up with?
38.674 grams.
Okay. I don't know what you did to come up with the right answer if you used tin as a limiting reactant. Let me ask you a question. Let me ask you this question. Did you use this number here to do the stoichiometry problem? Did you start with 24.41 grams of stannic oxide? Or did you start out with 100 grams of stannic oxide?
Neither.
What did you start with?
0.162
0.162 what? Moles?
grams. Or is it moles? I think, yes, moles.
Let me just do a quick thing here. Let's go with 24.41 divided by 150.708. And you started with 1.16?
Yeah.
162? That'd be okay?
Oh, so that's fine.
Yeah.
But I didn't use,
Well, you did. Because here's what you did. This is how much silver or tin stannic oxide you need, right? This amount here will react completely with all of this. So if I started out with 89.32 grams of silver carbonate, and I had exactly 24.41 grams of stannic oxide, when the reaction was complete, there would be nothing left. Both of these two things here would be gone. Now, if that's true, if both of them disappear completely, then they would be both considered limiting reactants because they both disappear. So what you did is says, well, if that's how much stannic oxide I need, that can also be considered to be a limiting reactant then, as long as I use that mass. Well, what you did, or what Isidro did, was he took this number here and divided it by its molar mass to find out how many moles of stannic oxide you started with. So I needed 0.162 moles of stannic oxide.
Because, and like all the stuff I use grams, so he used moles throughout the whole entire
And that's
thing,
fine.
and he broke it apart. But like, when I do that, I get a different limiting and excess reactant than you do.
You shouldn't. You shouldn't.
Because,
Breaking it into steps is only, you do this math problem here, then you get the answer, then you work with this one, you get the answer and work with this one. So you're not doing anything different. You're just doing it in steps. Is it okay? Yeah, that's fine. There's nothing wrong with it.
because in the first one I got the same limiting reaction, but in this one I didn't.
Well, you did get the same limiting reactant.
Did I just label them wrong?
No, because what you did is you said this was the limiting reactant, and all you did was figure out exactly how much of stannic oxide you needed. And that's the number you used in your stoichiometry problem. And that would be perfect.
But I didn't get that. I got that. I had excess of that.
Of what?
Of the silver.
Well, actually, you didn't. Actually, you didn't.
Why?
All right, let me ask you this question here. Let's do that boy-girl reaction again, okay? Now, here's my question. If I did a couple thing in this classroom, which one of the sexes will be the limiting reactant? The boys, okay? And can you tell me that with 2 boys, how many girls do I actually need? 2. Okay, so here's what I'm going to do. I did a stoichiometry problem, and I found out with these 2 boys, all I need is 2 girls. So what I'm going to do now is I'm going to forget that everyone else is here. So you're not here, 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 you're not here. So the only 2 people are here. Question. Now, no matter which one I use, how many couples am I going to produce if I did a stoichiometry problem? So if I took just 2 girls and said, how many couples can I produce with 2 girls? The answer would be 2. Assuming that I have an unlimited number of boys. You see what I'm getting at? So what I've said here is, if I took the 2 girls, because I found out that the girls were in excess, so I just forgot about the rest of you guys. And I'm just looking at these 2. This is how many I actually need, just 2. And I said, okay, I'm going to do a stoichiometry problem. If I had these 2 girls and an unlimited number of boys, how many couples are going to produce? 2. Okay. Now, if I had 2 boys with unlimited number of girls, how many couples are we going to produce? 2. So if I put that together, how many couples am I going to get? 2. So what you did is you did the right thing, okay, but you didn't look at it carefully, because what all you did was say, I forgot about all the other stannic oxide I had. I had 100 grams. I don't care about it. All I'm concerned about is the 24.41 grams of stannic oxide I started with.
But I used 100. I went to get all my words.
And that's one of the things that I'm going to tell you right now. If you don't put units after your numbers,
Oh, I did. When I did it, I did.
okay, all right, then, well, let's go to another problem. What do you say? Okay.
Can we do
All right.
the 4th one?
Could we do number 4? Yes, we can. Okay, number 4 goes like this. It says with 65.2 grams of copper chloride, copper chloride, for those of you that don't know, copper chloride is CuCl2. Reacts with 56.3 grams of calcium nitrate, where calcium nitrate is Ca parenthesis NO3 close parenthesis 2. What you're going to do is you're going to produce a ClCl2 and a Cu NO3 twice. And now what I'm going to do is slowly try to balance this equation. Yeah, it's 1 to 1 to 1 to 1. Yeah, it's all ones. Okay. So what I've got here is I've got a really interesting balanced chemical equation. So now I'm going to go through and figure out what the limiting reactant is. So I'm going to do a stoichiometry problem. And what I'm going to do is do a stoichiometry problem between these two things here. So I'm going to start off with 65.2 grams of CuCl2. And I've got to figure out what does 1 mole of CuCl2 weigh. And that's going to be 60 and 30. What is it?
134.452.
34. Is chlorine 34.5? What is chlorine?
35.453.
453 times 2 plus copper is 63.546.
15.456.
Okay, that's on tape 2 showing that the phone just rang. We won't mention that it's Canisius root phone. We won't do that. Because again, students are not supposed to have the phone on during class, and everyone knows that. Now she's texting in class. I think this is something that has to be brought up before the discipline board, and it's a good thing we're having this tape. Okay, so 1 mole of CuCl2 is 1 mole of CaNO3 twice.
We want to put them together.
Yeah, I was very confused there for a second myself. CaNO3 twice. And then I have to figure out what does 1 mole of CaNO3 twice weigh. So 15.9994 times 6 plus parentheses 14.0067 times 2 plus 40.078. I come up with 164.0878. So now I'm just going to have to do the math for it, multiplied by 65.2, divided by 134.452. I come up with 79.6 grams of CaNO3 twice.
Wait, that's what you got for the C and the 3 twice, right?
Correct.
But when I added the thing, I didn't get the
You didn't get 164? Let me go back and check just to make sure I'm right.
or maybe I'm
15.9994 times 6. That's 95.9994. Or 99.
I'll add enough. That's probably why.
Oh, how much did you put in the 5?
Wait, how many did you put in?
6.
4. So I forgot 2 then. Okay. I used the NO2 too. I didn't use weight.
Oh, because you used nitrite
Yeah.
instead of nitrate.
Yeah.
Okay, that'll be a big problem.
Yeah.
Okay, fine. Well, let's just continue here. Can you tell me which one is the limiting reactant then? This is how much I need. How much do you have of calcium nitrate?
56.3.
Do you have enough? No. So that makes this the limiting reactant. Because I only have 56.3 and I need 79.6. So now I'm going to do a stoichiometry problem and it's going to go 56.3 grams of CaNO3 twice. According to this, it's 164, and someone's going to have to help me because I just forgot it. 164.8 grams of CaNO3 twice. That's 1 mole of CaNO3 twice. We know that's a 1-to-1 relationship for every 1 mole of CaNO3 NO3 twice. I'm looking for calcium chloride, so it's going to be,
110.984.
I guess I'm going to calcium chloride. Okay, so it's going to go to 1 mole of CaCl2, and then for every 1 mole of CaCl2, it's going to be 70 something probably. $35.453 times 2 plus
It is one.
40.078, 110.984. So now I go ahead and multiply that by 56.3 and then divide it by 164.0878. And the answer I come up with is about 38.1 grams of CaCl2. Now you may want to check your math work because you messed up on the formula.
Yeah.
And-
So should I just go back and do it the way that I did it and see?
Yeah, see if it comes out the same. Yeah, go ahead and do that. Okay guys, we want to take a break ahead.